All right, so for those of us here in person, we have some people on Zoom. Just a few quick housekeeping things before I jump into the talk. As of today, we have to wear masks inside of federal buildings since we're in high community spread. Looks like everyone got the memo. Just a heads up, the speakers are going to take their masks off as each one speaks, just so people can hear them a little better. But for everyone in the audience, if you could keep your masks on, that would be fantastic. Restrooms are 2 left turns once you go out the back doors. For those of you who haven't been here before, feel free to leave at any time if you need to. All right, with that, we're going to get started. Welcome to the Naturally Speaking series. This is an ongoing series open to the public that our interpretation and education team put on a regular basis. And today's is extra special because it's on a new monitoring program that's based out of this park. Fog monitoring is something that many generations of resources staff have wanted here at this park. So this is a long time coming, and it's really exciting that it's happening now. Take my mask off. For those of us on the resources team, and as a natural resource manager in the 21st century, things aren't traditional anymore. You know, we were once told to kind of manage things at a baseline, how it looked in the past before, we had all this development in Southern California, and that's just not possible anymore with climate change. We just can't maintain historical baselines. So it's really important for us to understand where to put our resources, what to focus on. And fog dynamics is a priority due to climate change, due to the fact that it's the only way for flora and fauna in Southern California to get their water during our dry summers. Fog dynamics is something that's poorly understood in terms of how it's going to change under climate change, and it's very localized. So it's super important for us to kind of understand what's happening at Cabrillo with our fog, because that's really going to change how we manage natural resources here. This project is funded from a few different sources. So the Pacific West region and Scientists and Parks really liked our proposals, and we were able to pull together funding from a lot of different sources to do this. So I'm really excited for Brent and Taro to share that. And a quick introduction to everyone who made this possible. And we call ourselves the FOG team. So you're going to learn what this little paddle shape is here in the next 40 minutes. But we have Taro Katayama, Brent Wilder, Lauren Pandori, who's the marine biologist here, and myself on the team. But the core of the team are really Brent and Taro, who are joining us as graduate students as part of the Scientists in Park program. And I believe we're the only park service-wide that has 2 graduate students coming to the same site to do this. So it's been super amazing to see them work together. They're inseparable, they're dynamic, they're super good with data in the field, just ridiculously resourceful. And we had a lot of students interested in both of these positions. And the reason why we picked them is they had really different skills, but the same values. And one thing I'm really excited for you to see over the next 40 minutes is what you get when you combine good science with awesome teamwork. So with that, here's some behind the scenes here of the team, and I'm going to pass it over to them to introduce themselves and then kick off this talk.
Hi, everyone. Hi, everyone. Thank you again for coming to this talk. My name is Taro Katayama. I'm a Master of Environmental Management student at Duke University's Nicholas School of the Environment. At Duke, I study water resources management, where my interests lay in the social context and processes that drive water availability and use. I also really enjoy Duke basketball since I go there, and I'm really proud that we got the #1 draft class again this year. And here at a Duke tailgate, it was around like 40 degrees. I think it was pretty cold, but definitely proud of my school. And outside of the academics, I'm an enjoyer of pretty much anything outdoors, especially skiing with shorts in the springtime. So here's a little clip skiing in Maine. Hi, everyone. Oh. Hi, everyone. My name is Brent Wilder. I'm a PhD student from Boise State University. I am with the Department of Geosciences. I'm really interested in studying our water resources from the mountains. So I study, I'm a snow hydrologist, and better managing our waters and our downstream water resources. This is a pics from us in the field. And then I really enjoy surfing. This is a trip we took with the family to Hawaii. Had a great time. So love water, love working with water, love being in water. It's kind of just my element. We also wanted to give a huge shout out before we start the presentation to everyone involved with the project. So Environment for the Americas and Ecological Society of America for funding this project, or for funding us to be here. And also the Cabrillo National Monument and all the staff here, the resources staff, of course, for helping us with the project, the maintenance staff for helping us with constructing some of the fog equipment, interpretation and education for setting up this great event that we're all here tonight at, and also law enforcement for giving us rides to go collect data out into the field. Everything's really appreciated. If we were remiss if we didn't do a special acknowledgement to our mentors, Lauren and Lenon, who are in the audience tonight. This experience has been invaluable. We just, and really the brains behind the operation. So it wouldn't be possible without these two. Okay, so we are here at Cabrillo National Monument tonight. So as you know, or may not know, it's actually San Diego County's only national park. And while it's quite small, at roughly about 160 acres, staff around the park like to say that we park like a big park, with a grand total of about 1 million annual visitors that come by to learn about the history of Cabrillo, to check out the tide pools. And this is located in downtown San Diego. So you may be asking the biggest question, what is fog? And we've had a lot of conversations about how you define it between low-hanging clouds, fog, mist. I'm here to tell you the answer is about 50 feet. The NOAA, the National Weather Service, they define fog as low-hanging clouds that come within about 50 feet of the elevation of Earth's surface. This has to do with how the water vapor reacts, or not reacts, but how the physical interaction with the air pressure. And so specifically, we're interested in marine fog as it forms a result of these ocean currents and these weather systems that move into the coast. And ecologists such as us who research fog are interested in the water that is deposited on the surface of plants and leaves, and they use this to grow. And so here's some pictures of our plants. They are, like Lenon said, is super important for our native species here. They are dependent on the fog water, especially with our drier and drier summers and not so wet winters. So on the left here we have the golden spheris cactus, which is a rare species. And also on the right, we have a picture of a chamise that you can find right inside the visitor center, which is really cool. And so, yeah, we want to be able to take care of these species. And so a part of that is understanding how our climate is shifting and how it's affecting fog duration, fog intensity, and also just how fog is around the park in general. So we don't really have a great idea about how fog is accumulating at the park. And so there's kind of two sides to it, how it's changing with climate change and how it is in general. And so we really hope to understand that by putting out our sensors. Also, like we mentioned before, fog is a key aspect for moisture retention of plants. And so it would influence the live fuel moisture of plants, and aka how flammable the plants may be. So our little guy right there.
It's important to point out, this is a pretty novel study, and so this would pretty much be the first reproducible fog monitoring project at the parks of its kind. And we're doing it with some pretty state-of-the-art equipment. For example, this ClimaView station is a $3,000 piece of equipment that can monitor like 30 to 40 meteorological covariates at once. So very high tech, and we're looking to make it a reproducible project that can scale to other parks and other areas throughout the Mediterranean system as well. And with that, I'll hand it off to Taro.
Yeah, thank you, Brent, for laying out what fog is and why we're interested in it. As most of you are, I'm sure, aware, the mission of the National Park Service is to preserve unimpaired the natural and cultural resources and values of the national park system for the enjoyment, education, and inspiration of this and future generations. Our work aligns with the mission of the National Park Service by building knowledge which can lead to informed management decisions in the park. Some findings that may help management is pinpointing ideal locations for revegetation of endemic plants. Water is a labor-intensive resource, and knowing pockets of wetter areas within the park would be critical in helping the park staff plan where to plant these endemic species. Another way how our work will contribute to is by providing a broader understanding of fog dynamics within Southern California. As Brent mentioned before, there hasn't been very much documentation of fog in the area, so our work will provide a better understanding of the fog patterns in this area. And the last thing is that our project will be able to establish a long-term fog monitoring project that will be able to see how the trends of fog change over time and how that may be influenced with climate change on a longer time scale. Now that we laid out the context for which we are conducting fog monitoring research, I'll walk us through the three main goals that we had when we walked into this project. So number one, we wanted to create a functional and hardy fog monitoring program. In essence, we want this project to continue as long as possible. And for that to happen, it needs to be pretty easy to understand and also very easy to maintain. Number two, we wanted to create a thorough standard operating procedure, or SOP, so that the fog monitoring program can be conducted virtually anywhere that has fog. Since we did a lot of hard work of programming data loggers and stuff like that and made a lot of mistakes and some successes, people around the world can be able to easily set up their own fog monitoring project and use our SOP as a guide to help them along the way. And three, after all this was established, we wanted to provide some preliminary results of our data and see kind of roughly the trends of our fog on the field. Now that the goals of the projects are lined out, all we had to do was get the ball rolling, get the party started. First thing that we had to consider was the placement of the fog monitoring stations. We only have 4 stations to set up, so placing them strategically was really critical. So we brainstormed and thought about all the things that could influence fog around the peninsula, and we narrowed it down to these few variables like elevation, slope position, aspect, wind speed, the accessibility, visibility, vegetation type around. So yeah, and with all of those variables, we boiled it down to the most critical variables that we wanted to really look at for fog deposition and fog patterns. So here's this diagram that I created. It took me way too long to make. But essentially, you're looking at the Point Loma, the Cabrillo National Monument from the south, so right by the Coast Guard station, and you're looking straight north. So we have the lighthouse obviously on top, a bunch of lemonade berry, Nemo's dad looking for his son. And so yeah, so the first variable that we really thought was important was here are the fog monitoring stations, potential fog monitoring stations. Yeah, the first variable that we really thought was important was the way that the monument was facing. So from observations from park staff, we narrowed it down that a lot of the fog was forming out in the ocean and blowing in from the ocean side and then carrying around from the low elevation of the ocean side up towards the lighthouse and then around to the other side on the bay side, kind of where the Bayside Trail is. So this factor, oceanside or bayside, was something that we really wanted to capture with fog. This, of course, bayside or oceanside comes with all their covariates like wind speed and wind direction, so there's some wind that drive the fog up and around the peninsula. The next important factor that we wanted to capture was the elevation gradient. So what do I mean by this? As you know, the Cabrillo National Monument goes from the tide pools all the way up to here at the lighthouse, which is like 460 feet. So we wanted to be able to capture the difference of if fog was denser on the low elevation, and then does it blow up and disappear when it goes higher up in elevation. So we wanted to capture that. So we were thinking of potentially putting fog monitoring stations at low elevation, mid elevation, and high elevation. And we also wanted to control for elevation and look at the other variables that we consider, like the ocean side or bayside. So we wanted to also control for it and then have 2 monitoring stations at the same elevation. And lastly, going back to our goals of ease of accessibility and ease of maintenance, we wanted our fog monitoring stations to be really easily accessible and not too hard to get to. So we thought about that, ease of accessibility. And also we didn't want to impede or intrude on visitor experience, so we wanted to put our fog monitoring stations somewhere that's not in the view of visitors and a little bit more discreet. So here's a visitor looking out, enjoying the beautiful landscape. And yeah, these are all the variables that we really wanted to consider all kind of combined into one. With that, we set out on finding the best site locations. And quickly about this map, it's showing an overhead view of Cabrillo National Monument, and the colors represent the elevation. So green means low elevation, and then transitions to yellow and orange and brown, red and white. So that's high elevation. And here are actually the sites that we picked out. So we have one at Tide Pool, one at Nunu, one at Event Bluff, and these are all capturing that elevation gradient that we talked about before. And then all on the ocean side. And then we also wanted to control for elevation and look at the differences between ocean side and bayside. So we have Nunu and Spicy Bunker at the same elevation on different sides of the peninsula. Moving on, I'll talk about what a fog monitoring station looks like. It has many components. So first one right here, the climate view weather stations. We have 2 types of weather stations, but this one's a climate view. Captures some different meteorological measurements. Solar panels to keep the station running even if it's off-grid. It could just run on its own with the solar panel. And then the meat of the whole operation, we got the housing unit, which is weatherproof, and it has the data logger, batteries, and solar controllers. And then lastly, we have the leaf wetness sensors, which are on the ground right now, but will be in bushes soon. So these are a closer look at leaf wetness sensors, data logger, and the solar controller. So you may be wondering at this point, how the heck do you even capture fog? And we do that with the leaf wetness sensor I was just talking about. It looks like this weird little white paddle that's supposed to represent a leaf. And on it, it captures the electrical difference running across the surface of the leaf wetness sensor. So as fog rolls in and it starts to get a little moist, little water droplets form on the leaf wetness sensors, and as it does that, the leaf wetness sensors increase in millivoltage. So as the fog rolls in, collects on the leaf wetness sensors, the millivoltage goes up, it gets wetter, as you can see. as the null voltage goes up, it becomes way wetter. So from now on, you could think of millivoltage equals wetness.
And so here's a quick video of just a montage of us constructing the stations that Taro just went over.
So we have a lot of fun at the park.
And most of our construction went super smoothly. The solar controller worked great, so we used that to regulate the battery into our data logger, which it did require, we found that out, and so we found some innovative solutions. However, it wasn't all successes, there was some failures, including our first solar charger, the Sunway Solar shown on the right, and unfortunately we did lose this one, so.
RIP to our first one. This is just an ode in its memory. May it rest in peace.
And so, like Taro had mentioned, we had a total of 4 stations. And so 2 of them were the Climate View stations for about $3,000 a piece. And they are great stations. However, we wanted to have meteorological inputs at all 4 stations, and it would blow our budget out of the water. We actually didn't have the money to do all 4 with the Climate Views. And so we used a little bit of innovative thinking, and we found Davis Vantage Pro 2 stations, which are used in a lot of hydrology settings and research settings. They are at a cheaper price. Unfortunately, their data logger situation isn't super great with Davis, and so that required us to construct our own data loggers using a combination of open source software, which I'll show in the next slide, and hardware shown here. So we're soldering some pins on to attach the data logger. Here's the Taro. Oh, and then of course, always safety first. And so if you can imagine, this data logger, this little computer, is about the size of your credit card. And on top is it's called the Mediopie. There's like one person or one company in like Denmark that makes this. But essentially it attaches right onto the top to the pins that we soldered on there. And this works as a way to communicate with the Davis Vantage receiver. And so it'll log the data, it'll store it to its memory, and then we also, here's us troubleshooting, hour 20, some of the programming, but at the end of the day we were able to write some simple scripts to allow field scientists to be able to insert a USB in the field, automatically download the data to the USB, and then take it back to the Cabrillo servers, because it is a headless setup, meaning there's no monitor out in the field, and so instead of bringing a monitor into the situation, we just wrote some short programming to allow easy collection of the data. And so here's a photo of our final station, so I'll just kind of like make my way, leave the podium, very scary. So this is our station at Tide Pool. This is our lowest elevation site at 15 meters. And so it's actually right behind our volunteer van. So if you see it, that's the station at Tide Pool. This is Event Bluff, so this is our highest station, closest to the lighthouse. And here's Taro putting the finishing touches with this is the Davis Vantage station that we were just mentioning. And then our final 2 sites, I'm gonna walk over here to get some feedback. The final 2 sites, Spicy Bunker and Nunu, were at the similar elevations, 49 and 51 meters. But Spicy Bunker was on the Bayside Trail, and Nunu was on the along the coastal, the coastal trail on the ocean side. And so yeah, these are our 4 final stations. And then we also wanted a way to validate some of our data. And so we used the remaining of our budget to install 2 Browning trail cameras that we kind of transformed into weather cameras. And so they're also self-sufficient. They have their own solar panel, and they take a time-lapse series of photos every 10 minutes. And so here's us programming it. A little bit less low-tech. It's a little more straightforward. It's just programming on here, but still programming nonetheless. And then us installing it out in the field. And so, yeah, so we ended up having 2 cameras. This is the first camera at Cholla Minefield. We call it Cholla Minefield because there's a lot of Cholla cacti everywhere. And so, just like a caution to anyone who's collecting data there, it's a lot of Cholla. But it has a great view of the ocean side of the peninsula. You can see tide pools all the way down at the end of the photo. And so you can see this is collecting data every 10 minutes, and it'll also log the time that it was taken. And then our other station is facing the bay side. Shout out Andrew for helping us with construction on this. Did a super job, and we were able to have a very secure camera system here. And we also get some great views of the Navy ships that pass by too. And so of course the data doesn't collect itself. We don't have great Wi-Fi or cellular reception at the park. And so there wasn't really an option to do remote data transfers, and so data is collected in the field. Thankfully, it's a pretty small park, so it is definitely feasible. And so here's a quick video of us, just what that looks like.
Now back to the talk.
So as we mentioned before, when we go out in the field, the leaf wetness sensors, of course, collects the wetness of the fog, but the Climate View and Vantage Pro weather stations actually capture a lot of high resolution in different covariates like relative humidity, air temperature, wind speed, wind direction, rain accumulation, among many, many other things. So hopefully when we get more data, we'll be able to see how these variables relate to the fog and see if there's a pattern. So once we get the data, we wanted to see our hard work pay off, right? So we used a programming language called R to map out how the leaf wetness sensors were fluctuating on a day-to-day basis. So there's a lot going on in this graph. I'll take it slow, step by step. On the x-axis, we have hour of day. So it goes from 0 to 24, hour 24. So 0 is like midnight, 24 is midnight the other way. And it goes from morning onto the afternoon. And then on the y-axis, we have millivoltage, which again means wetness. Let's break this down a little further and just focus on the 25th of June. So we see that the leaf wetness sensor kind of spikes up at all these different sites in the early mornings of the early hours of the morning from like around midnight, and then it peaks around 9 a.m. and then drops down again when the fog dissipates, and then picks up again later in the night. And then if we compare this with June 17th, we see that the leaf wetness sensors are barely picking up any moisture there. So this would be considered a day with no fog at all. So it just stays at around 300-ish millivoltage. So you could clearly see the difference between the two. Here's a day with a lot of fluctuations, so fog, and then here's one without any fog. And this whole graph shows just on a wide scale, just the day-to-day fluctuations in the wetness and how fog comes and goes. So as you can see from the June 19th all the way to June 28th, we see a little bit of fog every day, and it usually picks up around midnight and then drops off again around 9 a.m. and then picks up again later in the evening. And so you can see this really cool graph where it's just showing fog come in and out on a day-to-day basis. So that's cool that we saw that on the graph, but we wanted to make sure that the leaf wetness sensors were actually picking up fog events. So we, of course, set out those cameras, and you can see on the top panel, you can see that that's a day, the 18th, if we go back. The 18th had no moisture at all. And you can see at 5:43 in the morning, the cameras show that it's a very clear day. And compare that to the bottom panel where we see similar time of day, 5:34. On June 21st, we see that it's very foggy and you can barely see anything. So it's nice to see that confirmation between the graphs and in person. And then we could compare these components and put them together, and so we get this really cool animation here.
And so this is going to step through minute by minute. And in a moment, the cameras are going to appear on the right. You see tide pool shooting way up in purple, and then Nunu in green, blue is Spicy Bunker, and then red is Bent Bluff. And then you can see that the fog subsides, and then quickly at 10 a.m. the sun comes up, and you can see that it'll play again as well, because I think I kind of missed that. So we'll let that play again, because that went kind of fast. And you can see that the camera started about 5 a.m. That's when the sun rises, so it goes only in daylight hours. And so this is the day of June 20th. 5 a.m. hits about here. And then you can see that the cameras pop on. Really dense fog, it's still accumulating. Fog clears, it still goes up a little bit. It takes a little bit of time for it to dry, right? So like the sun comes out around 10 a.m., temperature goes way up, and you can see the shadows disappear, and it dries off really, really quickly, actually. And so this is a great confirmation. We know that success, it's working. We didn't receive any rain accumulation in our rain bucket, so we know it was not vertical precipitation, only horizontal precipitation of fog. And so this was great news for our study. We were able to confirm occurrence of fog and intensity of fog from our sensors. And then here's just a snapshot of a still shot of the fog events for all of them. You can see once again the tide pool is really, really thick. So most of the fog is most dense and depositing water close to the tide pools at low elevations, about 15 to 20 meters above sea level. And if we go to the next one, we actually have some preliminary conclusions. Of course, this is only from June 18th to July 5th, so take this with a grain of salt. It's still like 2.5 to 3 weeks of data, but the great news is it's going to be long-term monitoring, so it'll continue on to the future. But we can see that so the y-axis is showing leaf wetness duration, and so what we did is we summed up the amount of time that the leaf wetness sensor was wet, and we classified that by the millivoltage being above 300, and as you saw in Taro's graph, typically at 260, 270, that's when it's flatlining with no moisture, no notable moisture. Above 300 millivolts is when you saw moisture, and so we summed up the amount of time that the wetness was above 300, and you can see that it's quite a long amount of hours, 200 plus hours, which is a substantial amount of water for these plants. And tide pool by far is the highest. And interestingly, between our elevation difference, Nunu and Spicy Bunker, that on average it was about 1.5 times wetter on the ocean side versus the bay side for similar elevation. And they're both on similar aspects too. So they're on both south-facing aspects, sunny aspects, but simply just the influence from the ocean side versus the bay side. And if we zoom in just at the ocean-facing sensors, so this was Nunu, Event Bluff, and Tide Pool. Once again, that's what these are showing here. And each of the stations has 3 leaf wetness sensors, right? And so that's what it's showing. But now instead of just the sites, we're showing it with respect to elevation. And while we only have 9 plots on this graph, right? it's a little tricky to draw conclusions at 9 points, but we can see that there is a little bit of a trend between the elevation of the sites and the amount of water that's being deposited at the sites. So that is confirming that we put the stations in the right site. So we are seeing different results from the stations, which is good. We didn't want to have the stations having the same wetness indicators. And so we plot this again, but this time we are plotting the daily wetness totals. So just a brief overview of that. Imagining the curves that you saw that Taro was showing, if we summed up all of those intensity data under the curve, you can think about it, that's why it shows like an integral sign, integral of volts over day. We're integrating all of the area under that curve for each of the days. So there's like 42 days, right? Or sorry, not 42 days. 20 days. But 3 leaf wetness sensors. So it ends up being about 42 dots for each of these. And you can see that once again, tide pools is very, very high. The intensity of the wetness is very, very high. And also we have the comparison between the bayside in Spicy Bunker versus the ocean side in Nunu, where we have that about 1.5 times higher in the median, which is shown in the middle of the box plots, between the green and the blue. And so what this project will look like in the future, this is a great example of reproducible science, and so we will be writing up a very thorough SOP, like Taro mentioned, where the hopes is that this will be continued at this park and maybe possibly at other parks too in the Mediterranean system to better manage parks by accounting for the water that's coming from fog. And we still have other questions. So for future scientists out there, are there microclimates within the park? Hopefully in 5 to 10 years, we'll have the data to answer those questions. And which covariates are most important in determining amount of fog? Like Taro mentioned, we have like 30 columns of data. So we have, wind gust and wind direction and wind speed and incoming shortwave radiation. So there'll be a lot of parameters to parse out in the years to come. It's all exciting research. We don't have any conclusions to talk about this time right on that, but of course, when this project continues further, there will be a lot of great scientific research that will come out of this. Thank you very much for coming, and we'll take any questions if you have any.
Sure.
Sure. I'm just holding up my letter.
So since this is hybrid, we're gonna take 2 questions from the audience in person, and then I'm gonna hand it over to Dan in the back, and he's gonna give us 2 questions from those joining over Zoom. So I see a hand from Gary that just shot up.
Yeah,
And I will repeat the question too, just so everyone can hear it.
Okay. Curious, I might sneak 2 real quick if I can. I'm doing a tour down Bayside Trail. People want to know how much moisture do these plants get just from the fog? Any idea that you can give me a percentage of their, moisture intake they need to survive? That would be number 1. And number 2, salinity have anything to do with it? Is this fog particularly salty coming in off the ocean?
All right, 2 questions from Gary. One being, how much water do plants on the Bayside Trail get from fog as opposed to rain or other sources? Second question was, does salinity impact anything?
Yeah, that's a great question, Gary. I'll go ahead and answer the second part of your question with the salinity. There are some studies that show that salts do deposit as far as 250 to 500 meters away from the ocean. Of course, it's dependent on slopes and the cliffs that can stop salt from propagating through the wind, and also from vegetation. And so that certainly is a part of it. This is a pretty small park at 1 kilometer, so it's tough to say with certainty the effect of salt deposits at this time. The first question was what?
Yeah, the first question with the amount of water that's being deposited.
Yeah, what can I tell the tourists?
Yeah, so our leaf wetness sensors are measuring wetness, so it's not necessarily the amount of water. And it would be really interesting to be able to see if we could graph out the millivoltage, the wetness with actual amount. So that was one thing that we were thinking about doing, was that we'd get like a little spray bottle, and then each spray we'll be able to know exactly how much water we sprayed, and then what the millivoltage equivalent was that. So that was just one idea we had, but we aren't exactly sure how much water is being accumulated with the fog.
Okay, I'm pointing a gun at you, give me a percentage.
I don't know.
I won't cite you. Okay.
All right, second question from the audience, otherwise I'll throw it over to Dan. Ooh.
Have you noticed the difference in the plant communities in like the different areas that your fog monitoring stations are at? Do you have different species?
Have you noticed different plant communities at the different sites where you're monitoring?
That's a really good question. Yeah, so it does vary with respect to aspects, like shadier aspects have higher density of plants, and also based on the ocean side versus bay side, and also like the elevation. A lot of the plants at tide pools are lower in height, which may be in fact due to like the salt of the soil or the salinity of the soil, but that's not my place to say. But definitely just being around the park, you do notice that the canopy height at tide pools is significantly lower compared to some of the other areas around the park.
And generally speaking, I think on the ocean side, facing vegetation are generally more green, just from a rough estimation, than the bay side.
Dan, do we have any questions coming in from Zoom?
Yeah, we have just one. No, actually, there's another one now. So, first one is, just to clarify, when you say fog, you are referring to what the weather people call the marine layer, correct?
Yeah, that's correct.
That's correct. June gloom, May gray, August, all the above. Yep.
Okay, then our superintendent put a question in here. He says, great job, nice to see the results of your work. How standardized are these monitors with other sites? Or are these unique with intended applications to other locations?
Yeah, so that's the great part about this project, is that there are other fog monitoring projects, such as the one on Channel Islands. Quick overview, Channel Islands folks do monitor fog for their coastal live oak. It's a little bit less reproducible, using a series of gutters and collecting water that's collected from the plants themselves. The advantage of using the sensors that we used in this project with Campbell Science and Davis, and the code and SOP that we are creating, is that this can be easily transferred to other parks, and these applications, or this instrument would be applicable for parks in the Mediterranean system and possibly around the globe. Yep.
And I would like to add that a lot of the research that has been done is with satellite imaging and seeing the duration of the fog just from these satellites. And with that, it's just too much of a large scale for our park, so you can't, with the satellites, our park would only be 1 pixel. So it wouldn't be able to identify the microclimates that we're looking for. And ours is more, I think we'd be able to have like ground truthing with the actual duration of the wetness with fog.
Just a follow-up to that answer as well, from Andrea. Some of the weather stations being used in this project are actually something that Keith Lombardo, who's the director of the Southern California Research Learning Center, is hoping to incorporate across all Southern California national parks. So we made sure to order the ones that went with that, so we can kind of use our resources to feed into multi-systems. And the Channel Islands fog monitoring is specific to their coastal live oak, like Brent mentioned, so it only captures the drip off of that tree, whereas this can totally go anywhere in any type of ecosystem and still give you the same type of data. I saw some hands pop up.
So if I understand correctly, to pull the data from these different things, someone has to actually physically go to them with the USB, upload the information, and then plug it into a computer and send it somewhere for processing?
Yep,
So
that's-
the question for people on Zoom was, when you collect data in the field, do you actually have to like go in and plug a USB at each one and then bring it, back to Cabrillo, the servers we have? And yes, it's not as easy as a TikTok. I wish they could just do it.
Yeah, that's correct. Yeah, we have to go out to the 4 stations and physically plug in the USB and also connect it to the computers. They could go for a really long time without someone having to go and collect the data. And right now, I think the cameras could go how many days?
355 days, but it's dependent on the SD card. So right now we have a 32 gigabyte SD card in it. So it could go for a year, but if we put a larger one, it could go for longer. As for the stations, just to know, I touched on it in the during the talk, but some stations do use mobile SIM cards for transferring data or Wi-Fi networks. The coverage is not great here at Cabrillo, especially along the coastal trail. Most often than not, you'll go down there and you just won't have cell phone service. And so it's more of a constraint, and also a budgetary constraint too, is that it's much more expensive to manage and to expense these mobile transfers of data. But like we said, with this being such a small park, this does work for our application, and it could work for larger parks as well that are remote, thanks to these data loggers being able to store quite a bit of data. So for example, we bought a 2 gigabyte extension for this data logger, which would allow it to go pretty much forever. These files are pretty light and would not require any more memory.
I think it was around 7 years.
And is the process pretty easy? Can someone just go plug in the thing and it kind of does it automatically, or is there?
So it's completely automatically, yep.
Oh, cool. That's awesome. Thank you.
One more question from the audience before we go to our Zoom participants.
Something from the data that I noticed was for all the different presentations of data leading up to the one that involved integrating that curve, it was really convincing that the tide pools, the tide pool site had the highest peak millivolts and the longest duration of wetness and stuff, but then once you did integrate it, it looked like the averages, like the mean millivoltage and stuff were kind of at the line or at the level of other ones, and so does that complicate your interpretation of the effects of elevation whatsoever?
Yeah, a little. Oh, sorry. Do you want to repeat?
So the question was, when you just look at the curves and how much area there is under them, it seems like a pretty dramatic difference. But then when you kind of pull out the means and go from, a 2D representation to a single number, the results aren't as striking. And why might that be? Hopefully that represented your question pretty good.
Yeah, that's a great point. That's something that we were noticing with the data as well, is that you could see from tide pools and Nunu that the median line here and here are relatively the same, and most of the points for tide pool are here, with a lot of the points up there kind of being more sparse. And so that's a great way to interpret it too. That's how I interpret it, that with more data, those points up there may become outliers. And so the change may be a little bit less dramatic than what we are seeing now. I hypothesize that elevation will still be influence on it, just not as dramatic as it looks at this moment, just from the dramatic fog storms that we got when we first started the program. But just if you compare between even tide pools and Event Bluff, our highest elevation site, of course there's no statistics, right? We didn't compare these statistically with t-tests or anything yet. But more data will need to be shown to convincingly say that elevation is a primary driver.
Dan, do we have any Zoom questions?
Okay, Keith Lombardo has a comment and a question, so I'll count that as one. His comment is, the USGS is interested in replicating this system in the cloud forest system on Santa Rosa Island. And his question is, would you be able to measure a rainfall event via the leaf sensors and millivolts? If so, then could you calibrate that to a rain gauge reading?
That's a great question, Keith. The Decagon manufacturer page do list that they have different signals between frost, fog, and rainfall that the leaf wetness sensor will pick up. We unfortunately haven't gotten any rain so far since we've installed the station, so it's tough to say. But I think in combination with the Climate View station or Vantage Pro, I think that is essential for parsing out the difference, because you need to have the rain accumulation bucket on top to ensure that the rainfall, say during midnight to 10 a.m. was essentially zero, like 0.1 millimeters, to confidently say that an excessive amount of fog occurred. I assume that it would be harder in more tropical areas or more humid areas if it does receive more rainfall, because then you might receive mixed rain and fog. So parsing out those two may be a little bit more of a challenge.
Keith, if you'd like to fund the park to find out this answer next summer when we have some rain and fog data, that would be great.
Okay, the second question now is, are there plans to study plant phenology in relation to seasonal fog changes?
Well, I'll answer that one because you guys are going to be out of here in a few weeks. Right now, no. The thing with the National Park Service is we have 10 million questions. Me and my staff always chat about these really cool things that we think are going on in the park. And there's always way too much to do with how many staff and how much time we have, in addition to the other things we're doing at the park. So if there's a researcher out there that would like to study that, please get in touch with us. I would say get in touch with me, but today is actually my last day at this job. But reach out. My staff are really passionate about what they do, and if there's a way we can facilitate research that actually feeds directly into park management, we're always looking for that.
And I can add to that too.
Okay.
Is that we are also planning to, on a semi-yearly basis, publish clean data for purposes of outside research or NPS research on the NPS database with all of our data here. So to help also promote future research efforts.
Yeah, I just wanted to congratulate the young men on their work and also say that this is really applicable, especially with being able to repeat this process for community science projects along the coast or any coastal community that could be utilized for accessibility and grabbing that data and then bringing it back to an NPS site or a state park or something to have scientists run the data. But I think it could be a great way to expand this project, not only NPS, but statewide or coastal regions wide. So thanks, guys.
For those of you on Zoom, Andrew Rosales, who's part of our science education team, was just commenting on how this system would be really great for community scientists to take this and do it all over the coast of California, over the Pacific coast. Really giving kudos to Brent and Taro for making something that's really reproducible. Woo. All right, any more questions from either the audience or Zoom? Keanu.
If ever the machines fell over, would you have to remove the day's results, or would you just leave it in there?
So Keanu was asking if the fog monitoring stations fall over, how does that affect the data?
So hopefully it won't fill up. So our data loggers could fill up to probably 13 years of data. So if no one's checking the data in 13 years, I think there are other bigger issues going on. But if it does fill up, in the case that it does fill up, it erases the oldest data first. And you can keep it going and collect the data and then keep the memory card going so that it collects all the data. And then, it'll just erase the oldest data first.
All right, Patricia.
Are there some potential failure that you guys are trying to anticipate that could happen with this?
Question about, are there any potential failures that you're anticipating in your SOP?
Yeah, we're most worried about I would say our data loggers that we programmed, because it is headless, and there is only one blinking green light that shows that there is data transfer going on. So you just plug in the USB and then hope and pray that it transfers the data. So I think that's the easiest thing that could go wrong.
But we are thinking about all these things. So in our SOP, we're actually making strategies to approach these problems if and when failures do arise. For example, for like the Campbell scientific ones, the most likely thing that will fail first is the rechargeable battery. And so we're taking steps if a scientist is going out there to collect the data and there's no display, we have like a checklist in our SOP, a really thorough checklist, so that way they know they can approach the problem and say, okay, we've got to recharge this, or change the solar controller, or we have to change the battery. So we're doing our best to preemptively think of problems, because they're bound to happen in a windy, outside, humidity. Generally water and electronics don't mix very well, but
Does the SOP include instructions on how to do a sad montage if you lose something? Dan, do you have more questions on Zoom?
Yes. Our superintendent would like to know when we're going to see you on TikTok.
This TikTok took a long time to produce, so I don't know if we have any time left in our internship to create another one. It was a multiple day affair.
this might be the only one. We're going to retire and just...
And then I have another one that's, do different fog types have different names like clouds?
The only one that comes to mind is the differentiation between mist and fog. I think that aeronautically, I think that fog is 1 statute mile of visibility, and I think mist is less. So I think it's just dependent on like the amount of visibility is kind of because fog isn't like itself isn't like it's a fluid thing, it's not a static thing. So the intensity of fog differs based on like the visibility. But as you saw in our daily charts that we were showing, is the intensity did vary with our leaf wetness sensors, and so the intensity of fog is being captured by our sensors.
I think fog also is driven by different weather patterns. So like the Santa Ana winds, I'm sure will influence fog in ways that, I don't know, like wind direction and wind speed like that, and which way the fog is blowing in from.
I did look into a particle sizer to distinguish between fog and mist, but it was $80,000 and way outside.
I'm just curious about the names Spicy Bunker and Nunu.
Oh, yes.
You have someone curious about the names Spicy Bunker and Nunu.
So a lot of the stations, as you can kind of take in from like Cholla Minefield, are just based on the surrounding when we were exploring stations for accessibility and for covariates. So Spicy Bunker is next to, could we actually pull up the slide next to like the final station slide? Yeah. Oh, so I guess you can't really see it. You kind of see the box there at the edge, but it's next to an old World War II bunker. And so that's where it gets the bunker part. And it has a spice bush that if it touches your skin, it's a little bit irritant. So it's just, I guess we just kind of combine those two together. And then this one, I think
there is a construction on this road back here, and forever it was like a one-way stoplight thing going on there. So I think the Park Service called it New Road, or maybe we just called it New Road. We just called it New Road. So,
but this is New Road.
Yeah. So the first iteration was a little bit, I think,
farther north,
and our leaf wetness sensors didn't capture, when we placed it out, it didn't go far enough. So we found a better spot where there's this like little valley, you can't really see here, but there's a little valley with a bunch of green. So we're like, oh, maybe in this area where it's very luscious, like there'd be more fog or something like that. So we decided to move the station and So that's why it's the new road.
How many different locations did you consider when you were looking at where to site the sample stations?
How many locations were considered before you picked your final four?
I would say probably around 10-ish. They all had code names too. One of them was called San Diego's best bathroom. The bathrooms that are near the lighthouse. Other ones.
There was one called Brent Taro, but it was just one that we had looked out from the Cabrillo statue one day. We're like, that looks like that was actually near Spicy Bunker, but Spicy Bunker had better accessibility. It had different covariates that we wanted to explore with the data. So it was an iterative process, but yeah, 10 probably was the largest amount that we had.
All right, with that, I'm going to wrap it up. Please feel free to ask Brent and Taro more questions after this. And I just want to end with the comment that Cabrillo National Monument, we often talk about it as a small park, and we're kind of struggling to get things done. But I think if you have the right people and prioritize the right things and put these things together, you can actually do way more than most people think at a small park. So this is the perfect example of it. And Brent and Taro have just done an amazing job over the last couple of months putting this together. It's really wild when you think about all the things they've considered, all the things they've tried, all the things they've built. I can't believe they've done it in such a short amount of time. So please give them a really loud round of applause.
Thank you.
And we'll stick around, so feel free to ask us any questions if you have any questions.